Hi, my name is Subha Chatterjee. Welcome to the channel Blooming Birds here. Today I will discuss a theorem of class 9 related to West Bengal board, that is what is parallelogram, and then I will introduce the theorem. Okay, so first I will say what is this one. ABCD here is a quadrilateral where AB is parallel to CD. AB is parallel to DC or CD, whatever, and also AD is parallel to BC. ABCD is a parallelogram where AB is parallel to DC and AD is parallel to BC. That means a quadrilateral whose opposite sides are parallel to each other is called a parallelogram. So here I will prove that if I will take one of the diagonal, means I have taken AC here, you also can take BD, the method will be same. So here I will prove that AC divides ABCD in two congruent triangles. AC divides ABCD in two congruent triangles. That means this triangle and this triangle both are congruent. Now I will write down the given here. So I will note down just the points. Given ABCD is a parallelogram. So obviously AB parallel to DC and AD parallel to BC. And also we have to say that AC is the diagonal here. AC is diagonal. So what is given? Since ABCD is a parallelogram, that means AB parallel DC, AD parallel BC and AC is diagonal. Now what is RTP here? Number 1, I have already told here that triangle ABC is congruent to triangle ADC. Number 1 RTP is both of the triangles are congruent. Number 2, AD equals to BC and AB equals to DC. Number 3, I will prove that the opposite angles are equal. That means we can say that angle ADC equals to angle ABC and angle DAB equals to angle DCB. So here RTP there are three parts. Number 1, congruent triangles. Number 2, opposite sides are equal. That means AD equals to BC and AB equals to DC. Number 3, opposite angles are equal. That means angle A equals to angle C, the whole one, and angle B equals to angle D. Now there is no construction here. You can observe that. So now I will start the proof part. First, I have to note down 3 points here. Why? Because since I have to prove that these two triangles are congruent, and we know that to prove congruency I need 3 conditions. So if I will draw two parallel lines here and I will take one transversal. So what are these angles called? You know that these two angles are called alternate angles. That means if one angle is just in the inner side of the one part and is another one is on the another side, then these two angles are called alternate angles. So similarly, if I will observe here that DC and AB. So suppose I have taken like that, DC and AB here. If I will draw it once more, I am drawing this portion separately. AB and this one is DC. Now if I will draw a transversal here, that means it is a Z shape. So these two angles are also called alternate angles. Now if I will plot it here, that means DC parallel AB, AC is transversal. So this one and this one, both are alternate angles. So I can note down here that DC parallel AB and AC is transversal. Therefore, we can say that angle DCA equals to alternate angle CAB. So, number 1 done for congruency. Now, number 2, I will take another pair of parallel lines. That means if I will take DA and BC, I am drawing it here, DA and this one is BC. Now I will join A and C. So here also, if you will observe properly, this is also just like an inverted Z. So if I will take these two angles, what are they called? They are also alternate angles. Now if I will plot it here, that means DA parallel CB, and I am marking this one and this one. So they are also alternate angles here. I will write it down that since DA parallel CB and again AC is transversal, therefore we can get that angle DAC equals to alternate angle ACB. So 2 points done. Now we need one more point for congruency, and what is that? If you will observe that AC belongs to both the triangle. Why? Because AC is part of triangle ADC and AC is also one part of triangle ABC. So we can take that AC is common side here. 3 points completed. So we can take triangle ADC is congruent to triangle ABC. Now what is the law of congruency used here? How will I get that? This one first, I have taken one angle, one side, and another angle also I have taken here. So if I will take these three conditions, means two angles are there and one side which is included between these two angles. So I will take the order properly, that angle, side, angle. Please note it down. It is not angle, angle, side, because if I will take angle, angle, side, then it will be angle, angle and another one side. I have not taken the third side here. So I have taken two angles and this side is included between these two angles. So it is called angle, side, angle. So I will write it down here. ASA congruency. Since these two triangles are congruent, we can say that AD equals to BC and also AB equals to DC, because we know that corresponding sides of congruent triangles are equal. I think it is better if you will write corresponding sides in place of corresponding parts. So since these are equal, opposite sides are equal. That means till now we have done number 1 and number 2. Now I will do number 3. Since these two triangles are congruent, we also can say that angle ADC equals to angle ABC. Means ADC equals to angle ABC. Why? Because we know that corresponding angles of congruent triangles are equal. Just like CSCT, it is CACT. There it was sides and now it is angles here. I also have to prove that whole angle A is equals to angle C. Now how will I prove? Already I have done here that angle DAC equals to angle ACB and angle CAB equals to angle DCA. These two already I have done. Now I will just add both of them. Why? To get angle A properly, I have to add both of them. So I will write angle DAC plus angle CAB equals to angle ACB plus angle DCA. Now angle DAC and angle CAB. So DAC means this angle and CAB means this angle. So if I will add both of them, which angle am I getting here? I am getting angle DAB equals to, now ACB means this angle and DCA means this angle. If I will add this both of them, then also I am getting the angle DCB. So angle DAB equals to angle DCB. This one is also done. Hence the theorem is proved here. Thank you.